how long would this electronic waste possibly last? Because we're going to need a lot of this, and we're only going to need more and more year after year, right?
Right. So because we have so many tailings all over the country from former mines that are sitting there, that are waste sites that have to be managed, and these waste sites, they will gladly let you take it off their hands. They have to manage it, make sure it doesn't get into the environment, or they're. Now, we can also deal off of other types of waste. We can deal off of what's called red mud, which is bauxite residue. It's the residue that's left over after aluminum production. As far as the eye can see, you can see these red fields, big cakes that are 10 feet high, and just as far as the eye can see. This is hematite. It is iron mixed in with the aluminum and some titanium. How do you get, these are tailings, meaning that they're too contaminated with iron to get at the aluminum that still resides in there. So we can just flash this. In an instant, we pull out the iron, and that can then go right back into the normal aluminum purification. So we're cleaning up waste sites, things that were too expensive. But when you make it so that it's economical, you make money by cleaning up the site. Not only do they pay you to clean it up, then you take that material, you make money. That's the only way to get these sites cleaned up. So we have the red mud, and then we also have mountains of fly ash in this country. Fly ash is the inorganic residue from coal burning. So you burn coal, the carbon burns away, you're left with the inorganic material. It's aluminum, calcium, silicon, and then it has other metals in it. So we can get these metals out. We've demonstrated it. Now, I would rather work off of electronic waste because it has a higher percentage of the metals that I want, but we've demonstrated it. So you have these huge waste facilities that are there. So we could run for a long time based on this. But if we had to supplement with these wastes with ores, we might use ores, but I would rather get their tailings, because the tailings for me are useful. So, for example, even in lithium mining, again, lithium is a critical metal. We need it for all our lithium-ion batteries. Every electric vehicle, every cell phone has lithium. So the tailings, a lot of times, the particles are too small for them to deal with. That doesn't affect me at all. I can run off the small particles. So I can take the things that have no value to them and use them. There are other mines that are what are called, what they have. They'll have the rare earth elements, but not as oxides in these mines. They'll be as phosphates. That's useless to them. It's hard for them to process the rare earth element phosphates. Doesn't bother this process. We can take what is to them useless material and turn it into good material. And so it takes off the table this idea of we've got to get our elements, because if we can't get these, if really we can't get these, there will be wars fought over this. I can guarantee you that.
The one thing that strikes me here is that, this is also something that Americans could actually be rallied around, because there is a lot of this electronic waste at home, for example, right? And I think this, these export controls, which the Chinese Communist Party threatened America and frankly the entire West with, were a crystallizing moment. At least I hope that they were a crystallizing moment. So I wonder if this doesn't even have a kind of a patriotic dent in it, to it, or an element to it.
Yes, if you could tell people that if you take your electronics that you're getting rid of and you put them in a certain container to be carted off, this is patriotic. I mean, that would be a further incentive for people to do it. So these things are there, but also what we're getting from the Trump administration is we're getting a guaranteed floor price. So they're saying we will pay you X amount for your rare earth elements, because what will happen is this is the way some countries operate. So they don't like us developing this business. They will artificially lower their price in a way that we could never compete. and drive us out of business. As soon as we're out of business, they will raise the price back up. So what the U.S. government is already doing, preemptively saying, we will guarantee you this price. And it's not really the U.S. government supplementing it. That's the price that it's going to ultimately be sold for. And so by doing this, they will allow us to get this start, that we won't be driven out of business. So we're getting actually a lot of help and consideration from the U.S. government to say, hey, we really have to do this. So this is an important thing for the country. And we offshored so much of our manufacturing. We're trying to reshore a lot of that, and because we see what can happen. And President Trump went and he recently, as you know, made a deal, and China said, okay, we'll start selling this to you again. I wonder how much of that was just out of the goodness of their hearts, or because they saw these other technologies coming online. Because when you make it difficult for somebody to get something, they will figure out another way. It always happens. I saw it happen in oil and gas industry with guar for fracking. The Indians kept raising the price, and then boom, they came out to something called slick water, which you add polyacrylamide, a chemical, so you pump at a fast rate. You find a way around. But interestingly, after President Trump left, a couple weeks later, they say, yeah, we will sell it to the U.S., but it can't go into any of your military hardware. So again, we have to have our own capability. We can't be held to the whims of other people around this. And that technology that the Chinese are using, that was developed in the U.S., actually. It was developed in the U.S. during the Manhattan Project because we had to get because when you get uranium, you get rare earth elements with it. We had to separate the rare earth elements to get the uranium, so we figured out how to do all of this separation. That technology was purchased by China. Actually, it started to get purchased in the 60s, again, heavily in the 1980s, because the U.S. was getting out of the business, because in the rare earth element business, you were pulling up uranium with it. Now we want the rare earth elements. We didn't need the uranium. And that was for us a radioactive waste, which is very expensive to get rid of. And so the Chinese bought the technology. And again, we didn't realize that we were selling something that turned out to be very important to our country.
Before we continue, just tell me a little bit about yourself. I mean, you seem to know quite a bit about all this. I know you do.
Well, I'm trained as an organic chemist, but I work quite broadly. I've been a professor for 36 years. I'm a professor of chemistry, of material science and nanoengineering, and computer science. So I have to know things across many different fields, but I've started 17 companies that range from pharmaceutical companies to materials companies to electronics companies. So I've worked in this space broadly, always from the chemical perspective, but then even building devices and thinking of things electronically. So my group, I have a big research group, and so it thinks quite broadly. And I've consulted a lot on the Department of Defense, served on committees related to the Defense Science Board and the Defense Science Study Group. So I've looked at it from the military side as well.
I should add, you said you started 17 companies, but quite a number of these companies have been quite successful.
Well, they've made some people some money.
And so you're also attuned in the business realm, I guess.
Yeah, I don't like it, but I let other people do that. And I'm never an officer or director in the companies. That's how I can have 17. Mm-hmm. I don't run it. Other people do. I don't particularly like the business side. I'm forced to balance my checkbook, so I have to know a little bit. But other people run it. But I'm familiar with how businesses work. Yes.
Right. Well, exactly. And it's the right product at the right time. It's kind of a mantra like this, right? Of how you get business success.
Right. The thing that makes this a little bit hard is that these metal prices can fluctuate a lot. So you're subject to that. Now, one of the metals that does not fluctuate a lot is gold. Now, still gold can go up and down, but it's not as big of a fluctuation as many of these other metals. And so what we're always going to have is the gold operation. Now, gold is not considered a critical metal. It's not that China is not selling us gold. But that's not a problem. but we've now been solicited by jewelry manufacturers, say that for them, the electronic waste, gold, is a great selling point, because some people don't want to buy jewelry that has caused people to have mining, because mining operations are inherently hard on the environment, and gold mining often is cyanide based, and so it's a messy, dirty, toxic operation. And they say that there's a good market for gold jewelry that is made from gold that is reclaimed from waste. People like that. So they will pay us top dollar for that gold. So the gold will be for us like a buffer that will always be purifying gold, because a lot of electronic waste has gold in it. Sometimes touch screen displays, which we say are indium tin oxide, has indium and tin. There's actually more gold in a lot of these than there is indium and tin. So we grab all of that gold. We're not going to discard gold because there's a very high price on it. The other thing that for us is very good that we're moving into is catalytic converters. If you've ever had a catalytic converter stolen from underneath your car, which a lot of people, it's $2,000 to replace it. That is just a metal oxide that has platinum, palladium, and rhodium. Those three metals are needed to take the carbon monoxide that comes out of an exhaust and convert it to carbon dioxide, to take it from a very toxic gas to a much less toxic gas. And then some people would say not toxic at all. So you convert it to carbon dioxide. You have to have that. But the catalytic converters, after about 10 years, don't work very well anymore. So all of those are recycled. For us to pull the platinum, palladium, and rhodium out is much cheaper than for the traditional processes. And platinum, palladium, and rhodium are very high priced, but particularly rhodium, and then platinum, and then third palladium. But all of these are what are called precious metals, and not just critical metals, but precious metals, which means that the price on them is much higher. So we can get a much higher return from these. And already in place is a system to reclaim catalytic converters. Catalytic converters are already reclaimed. There are companies that all they do is they have the equipment that tears these things open and reclaims this material, and then we would get this material from them and turn it around, because our process will be cheaper. And also, we're not popping over in cell phones and things like that. There are already companies that do that because they are trying to reclaim certain parts of these phones to reuse in refurbished phones. So we get from them something, and this is good for the bottom line of their business, because now they have an avenue to sell parts to us that they wouldn't use anyway, and then we would reclaim those parts just by pulling the metals back out. And actually, we've been talked to by other companies that really want the glass that's on the iPhone, the glass that's on the cell phones, because that glass has lithium in it. And that to them is a good recovery source. That lithium makes it a very tough glass. So they're reclaiming the lithium that's in the glass. So in many ways, it's sort of like American Indians, where they used every part of the animal. Even in these printed circuit boards, we've already got in place in this company, because when they flash it, the plastic is turned into carbon monoxide and hydrogen. Why hydrogen? The hydrogen-hydrogen bond is much stronger than the carbon-hydrogen bond, so the hydrogen atoms prefer to come out as H2. That H2 is a tremendous fuel source, so you can use that to run generators to run your company, or you can take the carbon monoxide hydrogen mixture, which is what's called syngas, S-Y-N, syngas, and that is used in the chemical industry every day for making a lot of the chemicals that we use on a routine basis. That mixture of carbon monoxide and hydrogen is very good. It's used in a reaction called the hydroformylation reaction. And the plant we're building is very close to the Houston ship channel that uses a lot of syngas. So there's an outlet for that. So even the plastic from the printed circuit boards is to us valuable.
Basically, you're telling me that there really is very, very little waste here in the process.
Very little waste in the process. There will be some things that we can't use, but very little waste. And so it's It's a big win. It's a big win for our country. It's a big win for the environment. So the company has already been taken public, and so people can just invest.
There's also military waste. That's another piece, right?
Huge. Military
Right.
waste is huge. Right. You get a retired aircraft. So a retired aircraft that has a lot of the rare earth elements and the critical metals, a retired submarine, retired batteries, lots of military waste and lots of flame retardant material in the military. All that antimony we can get back out. So yes, that is for us a constant source.
And I'm trying to imagine what this looks like. And in my mind, I was sort of imagining, a sort of a chipper that is fed all these different basically types of waste, but a very, very industrial. What does this actually look like? Paint me a picture.
So I have never walked into the company. Yeah, I start the company, and there's a reason for that, is that I'm a professor, I'm trained to speak. And so I don't even want to learn about their know-how, how they do the conversion. Yeah, I'm a scientific advisor. I say, you can try this, try that. But I can tell you the basic layout. It's exactly what you say. There is a way to take large pieces, it chops it up into small. So grinding and breaking things up, the machines for that are already well known in the industry. We don't have to develop that. So it breaks it up into small pieces. It will go into an environment where it's heated to extremely high temperatures. And the way we do it in our labs is what's called resistive heating. And so it goes into resistive heater. It heats up very high while chlorine gas is injected in. Chlorine is a commodity chemical. It's used in very large volumes, all of PVC, polyvinyl chloride, plastic. I mean, it's all use chlorine in very large amounts. And so the chemical engineering for the use of chlorine gas is extremely well worked out. Safety operations for capturing it, any excess is recycled and brought on through. So you heat it up under chlorine, and then these metals come distilling out, and you trap the metals as they come distilling out, and you individually distill them out based on their boiling point or their temperature, and based on what's called the free energy of formation of the chloride. At what temperature did the chloride form, the metal chloride, and then at what temperature does the metal chloride come distilling out? But metal chlorides distill out at relatively low temperature compared to metals and metal oxides. Sometimes 3,000 degrees lower temperature. Yeah. We can distill out these metal chlorides, and then we will sell them as metal chlorides, or you expose them to air, an air oxidation, and they'll convert back to metal oxides, and we'll trap the HCl that comes out. That's basically how the operation runs. Comes in as these printed circuit boards and comes out as metals in different metal streams, and then those are sold.
Something that I really like about this model that you're describing is that for a relatively small investment, it's almost like, I don't know, want to use the term modular, but you can imagine, people licensing this technology and sort of, starting up these relatively small operations, all over the country and it feels like an actual method to within a year's time, because that's kind of the rough window that I think the US has to figure this out. Actually, would it be possible to get independent within a year's time? Is that?
I don't think we'd be running that fast to get the US independent in a year's time. But, what it would do is it would give us a map to get independent. I could see it happening within 5 years where we're really independent on this. But if we had help, because we are licensing it out, we're licensing it out in some of the for example, for the bauxite residue, the aluminum work, we're licensing that out, and we could build many of these companies. And yes, they are modular. They go in. And for a manufacturing site that you can get these things going for a few tens of millions of dollars, that's not very much when it comes to this type of manufacturing.
The one thing that strikes me is you did mention that it takes a lot of electricity, a lot of energy. And that said, I was just at a roundtable of energy experts, and the discussion is entirely around how do we deliver enough power to run the data centers for AI, essentially. I mean, that's the bottom line. This would sort of fit into the rubric of trying to, increase, build, we're talking nuclear. Nuclear all of a sudden is, okay, again, basically anything goes.
Yes. Overall, our energy is less than the traditional recycling operations and traditional mining. Our energy is less. We need a lot of power for short intervals of time. When we do that flash, it may only be seconds that we bring in high electricity. Our electricity overall demand is much less than a data center. In fact, one of the ways to get cheaper electricity is you build something next to a data center because they're already bringing in a lot of electricity, and you pay fractionally more than what the data center pays. So the electric company will gladly siphon it off to you in those bursts when you need it. So there are ways to do that, but compared to the data centers, we're nowhere close, and we are less than the normal industry. But what we need, which is unusual, we need bursts of electricity. So there's where we may bring in a 4 megawatt line into the system so that we can bring in a lot all at once, but then it's turned off between these operations. So you flash and you're done. New material is brought in, flash, and you're done. And so it comes in on a belt.
So bottom line, does this solve the entire problem with communist China when it comes to these metals?
Yes, these metals are now called critical metals because we can't get them anymore. So they've been named critical metals, which is rare earth elements plus a number of other metals. This will solve the problem. Now, it won't solve it overnight because we have to gear up. And so, but it could solve the whole problem within 5 years. If we push this process, it could solve our problem within 5 years, where we would get to a steady state where we're able to produce as much as we use. If we have to bring in more, we have these mountains of tailings that we can access, and we have these constant mountains of printed circuit boards. If we had to supplement, we can run off the ores. So if you had to do mining again, we can always run off the ores. But this would solve it. We will be able to manufacture what we need.
Well, Jim, this has been an absolutely fascinating conversation for me. A quick final thought as we finish?
This for me is so much fun. To be able to go in a laboratory, devise something new, publish papers, graduate students, that's my business. That's what I do. But then to see this translate into a company always brings it up another level. But now, where it has so much need for this country to be able to solve a critical problem for the country, this is like every scientist's dream.
Well, Jim Tour, it's such a pleasure to have had you on.
Thank you.
Thank you all for joining Jim Tour and me on this episode of American Thought Leaders. I'm your host, Jan Jekielek.